Topic is Beckmann Rearrangement. Now this is name of the rearrangement, Beckmann Rearrangement. This is acid catalyzed rearrangement where the formation of carbocation takes place. What is the starting compound of this rearrangement? It's a ketoxime. Now this is ketone. This O, if it is replaced by NOH, then it is known as ketoxime. Ketoxime. So this is the starting compound for this rearrangement. This is acid catalyzed rearrangement. So here we are seeing this rearrangement mechanism. H plus acid. In this compound, this is oxygen bearing lone pair of electron. This H plus will attach here. This lone pair of electron will attack on this proton. So the compound next is intermediate is NOH, and this H plus attached. So this is the compound. Now this is oxygen having 3 valency, therefore plus charge, because this is unstable, so bond will be broken. This oxygen is more electronegative than nitrogen, so the electron will be taken, both the electron will be taken by oxygen, and a stable product H2O will form this H2O. Now you see here what is happening. Nitrogen is giving electron to this oxygen, so nitrogen will have plus charge. Now this is stabilized by breaking one of this group and attaching to this nitrogen. This group will be broken with electron and will attach to the nitrogen. But the point is that according to this reaction mechanism, this OH group opposite to this OH group, which group is present, that group migrate on the nitrogen. According to stereochemistry of this rearrangement, the group migrate which is opposite to this OH group, anti-position to this OH group in a space in stereochemical aspect. Now this is where here we have reached. Now assume this R group is anti-position to this OH, so this R will migrate with electron on this nitrogen. So the compound will become now N R double bond C R dash. Now you see here, because this R group is going with electron, so plus charge will be developed on this carbon. The carbocation is formed here. Because reaction is taking place in polar solvent water, so water will attack on this carbocation. Next step will be, this is as it is, carbocation, this plus charge will be attacked by this water molecule oxygen having lone pair of electron, so oxygen will attach here. This is H2O. Now this is unstable, one bond will be broken, one of this hydrogen bond will be broken, electron will be retained on the oxygen. So this is breaking, so there is loss of one proton taking place. here you see in this rearrangement H plus proton is attached here in this step, and here it is removed. So this is a catalyst, as it is a catalyst, playing role of the catalyst. Now what is happening here, you see this proton is lost, oxygen now became neutral. Then we can draw like this, C double bond N R dash, sorry, R R dash and OH. This is converted to this. Now next thing is that this nitrogen is more electronegative than carbon, so electron will be pulled toward nitrogen, and because carbon will now bear a plus charge, delta plus, so electron of this lone pair of oxygen will be shared. Double bond will form here between this carbon and oxygen, and nitrogen will have minus charge, and because here are two bonds and this hydrogen, so oxygen will have plus charge, so again it will lose H plus, and here because electrons are going on the nitrogen, so it will have minus charge, so this hydrogen will attach on this nitrogen point. You understand what is happening? Nitrogen is pulling electron, minus it is forming, therefore this carbon will form plus, the electron will be shared from this oxygen, so now carbon is neutral, but carbon and oxygen double bond is forming here, making this oxygen plus charged, because 3 valency will be here of oxygen, this 2 and this 1 3, so therefore this H plus will be removed, keeping electron with the oxygen. Now H plus will attach this N minus, so next compound will be this R dash, as it is C and double bond O, ketone, hydrogen is gone on the nitrogen, this R as it is, so this is R C double bond O NH, this is amide forming. So in this Beckmann rearrangement, this R C double bond O R dash is converting to this R dash C O NH R, so one nitrogen is coming here, making this amide